Hey everyone, and welcome to this special explainer from Learn AI with Brema. We're about to peel back the curtain on artificial intelligence. My goal? To give you a super clear, no-nonsense look at what machine learning really is and, how it's basically running the world you interact with every single day.
All right, let's kick things off with a question I bet you've asked yourself. Ever been scrolling through Netflix and it just serves up the perfect next show? Like, it's almost spooky how well it knows you. Or how about your email inbox? How does it magically sift out all that junk? Well, spoiler alert, it's not magic, it's machine learning.
So to really get what that means, you gotta understand how different it is from old school programming. See, traditionally, a programmer has to spell out every single rule. It's like, hey computer, if this happens, then you do exactly that. You feed it the rules, you feed it some data, and bam, you get an output. But machine learning, it totally flips that on its head. With ML, you give the computer a ton of data and the answers, the outputs you want, and you say, you figure out the rules. It literally learns from the examples we show it. It's a complete game changer.
Okay, to make all this super easy to grasp, we're going to use an analogy for the rest of this explainer. Think of building a machine learning project just like building a house. And what's the very first thing you need for any good construction project? That's right, a solid blueprint. You have to know exactly what it is you're trying to build. So in our analogy, what is this house we're building? Well, the blueprint, at its very core, is for a system that can learn. And that's really what machine learning is all about. It's the science, or maybe the art, of getting computers to spot patterns in data. Why? So they can make smart predictions about stuff they've never ever seen before. And the best part? No one has to sit there and manually code every single possible outcome.
All right, so you've got your blueprint. But you can't build a house without materials, right? You need your wood, your bricks, your concrete. Well, in the world of machine learning, there's really only one raw material that matters. It's data. And believe me, the quality of that data, it's everything.
And this leads us to maybe the single most important rule in this entire field. You can have the fanciest, most powerful algorithm in the world. I mean, the best construction crew on the planet. But if you give them bad materials, you're going to build a garbage house. It's as simple as that. Every single time. Garbage in, garbage out isn't just a saying here, it's the law. Your data quality is the foundation that everything else rests on.
So what does this good data actually look like? Well, it usually breaks down into two key parts. We call them features and labels. Let's stick with our house building example. Say we want to predict a house's price. The features are all the input data, the size, number of bedrooms, location, that kind of thing. And the label? That's the answer we're trying to predict. In this case, the price. So think of it this way. Features are the questions, and the label is the answer.
Okay, so we've got our blueprint, we've got our high-quality raw materials, our data. Now it's time for the fun part, the actual building process. And this is all about choosing the right model. Think of this as picking the right construction style for our house. Are we building a modern minimalist home or a classic Victorian?
So generally speaking, there are three main styles to choose from. First up, the most common one, is supervised learning. The easiest way to think about this is it's like learning with an answer key. You show the model a bunch of examples where you already know the right answer. Next, we have unsupervised learning. Here, you just throw a whole bunch of data at the model with no answers, and its job is to find interesting patterns all by itself. And finally, there's reinforcement learning. This one is just like training a pet. The model learns through trial and error, getting little rewards for good choices.
And you can see these different styles all over the place. Supervised learning, that's the workhorse behind a spam filter and those house price predictors we talked about. Unsupervised learning is brilliant at finding hidden groups, like when a company wants to segment its customers for better marketing. And reinforcement learning, well, that's the powerhouse driving some of the coolest stuff out there, like self-driving cars, figuring out how to navigate a crazy intersection.
So our house is built. Awesome. But hold on, we're not ready to move in just yet. I mean, you wouldn't buy a house without getting it inspected, would you? Of course not. And it's the exact same idea with our model. We absolutely have to do a quality inspection to make sure this thing is solid, reliable, and actually works.
So how do we inspect a machine learning model? Well, the most important step by far is something called the train-test split. It's simple, really. We take all our data and chop it into two pieces. We use the bigger chunk, maybe 70%, as our training data. This is what the model actually learns from. But the other 30%, we lock that away. That's our testing data. And this is the crucial part. The model is never allowed to see this test data while it's learning. But why? Why do we do that? Why would we hide perfectly good data from our model? Doesn't that seem kind of counterintuitive?
It all comes down to one single, incredibly important idea: generalization. Look, we don't want a model that's just a good student at memorizing the answers. That's useless. We need a model that actually understands the subject, one that learns the real patterns so it can handle brand new problems it's never seen before. That testing data we hid, that's the final exam. It's the moment of truth that tells us if our model actually learned the material or if it just cheated by memorizing the study guide. And doing this helps us dodge a massive problem in machine learning called overfitting. This is what happens when your model learns the training data too perfectly. It doesn't just learn the patterns, it memorizes all the weird little quirks and noise in the data too. The suit analogy is perfect. Imagine a suit tailored so precisely to one person's body that it's unwearable for anyone else. That's an overfit model. It looks amazing on the one person it was trained on, but the second it tries to work on something new, it just completely falls apart.
Okay, our house is built. It has passed the quality inspection with flying colors. So, what now? Now we get to the final, and honestly, the most important phase of all: opening the doors to the public. This is where we stop talking about a cool project and start talking about a real product that people can actually use.
And let me tell you, this is a hard truth that separates the rookies from the pros. You can build the most brilliant, most accurate model in the history of the universe, but if it just sits on your laptop in a file, what we call a notebook, it has exactly zero real-world value. None. The value, the impact, the magic, it only happens when that model is deployed out into the world for people to use.
And this whole process has a name. It's called ML Ops, which stands for Machine Learning Operations. Think of it as all the plumbing, wiring, and logistics needed to take a model from the clean, safe environment of the lab and get it working reliably out in the messy real world. It's the crucial bridge that turns a great idea into something that actually makes a difference.
Because here's the thing about the real world. It's always changing. So the job is never really done. A machine learning model isn't something you build once and forget about. It's a living thing. We develop it, we deploy it, and then we have to constantly monitor it. Why? Because the data out in the world changes. We call this drift, and over time, our model's performance will decay. So we have to retrain it with fresh data, which starts the whole cycle over again. This isn't a straight line, it's a continuous loop. And that is the secret to building AI systems that actually last.
And there you have it. From the initial blueprint and gathering our data, to picking a building style, running a quality inspection, and finally opening the doors to the world. You now have the complete roadmap for how a real machine learning project comes to life. So the only real question left is, are you ready to grab a hard hat and start building your own?
Look, what we've covered today is the 30,000-foot view, the essential foundation. But if you're feeling that spark and you're ready to really dive deep and get your hands dirty, then I invite you to check out the full Machine Learning Masterclass from us here at Learn AI with Brema. It truly is your complete blueprint from mastering AI. Thanks so much for joining me today.